Hi all, this is Shashikla, Assistant Professor, Department of ECE in Care College of Engineering. So today's topic is on mesh analysis, comes under the topic of steady state solution of DC circuits in the BEEE paper. Subject code is BE3251. So what is mesh analysis? Mesh analysis is defined as the method in which the current flowing through the planar circuit is calculated. So planar circuit is nothing but that is defined as the circuit that are drawn on the plane surface in which there are no wires crossing each other. So therefore mesh analysis can also call loop analysis or mesh current method. Okay, so we are applying Kirchhoff's voltage law here. So let us see the mesh analysis in problem. So the first equation problem is write the mesh equation for the circuit shown in the figure and solve for the current in 12 ohm resistor. So they gave the so the circuit is given. For the given circuit, we need to find the current in the 12 ohm resistor. The first step for finding the current is to find the mesh currents for each loop. Each loop means we are having 3 loops in this circuit as shown in the figure. So loop 1, loop 2, loop 3, and the corresponding currents flowing through the loops are said to be I1, I2 and I3. Okay, so we need to find the mesh equation for loop 1 first. So in order to find the loop 1 equation, the first equation comes like minus 4 I1 minus I2. Why we are writing minus 4 is, for mesh analysis we need to write the resistor values in terms of minus. Okay, so I1 minus I2 indicates that particular resistor, this resistor. So it lies between loop 1 and loop 2. So we are writing the mesh equation for the loop 1. So I1 minus I2. Okay, so minus 7 is nothing but this particular resistor, minus 7. So it lies between loop 1 and 3, no? So we need to write that as I1 minus I3. Okay, plus 480. 480 is nothing but the loop 1 voltage source. Okay, so we got the equation for loop 1. That is nothing but minus 4 I1 minus I2 minus 7 into I1 minus I3 plus 480 is equal to 0. So simplifying this equation, we will get 11 I1 plus 4 I2 minus 7 I3 is equal to 480. That is your loop 1 equation, mesh equation. So we need to find the loop 2 equation. So for that, how we are writing is minus 12 I2 minus 12 I2. Look at the loop 2 equation. So we are having 3 resistors in the loop 2. The first resistor is minus 12. So as I said before, in mesh analysis, by writing the resistor value, we need to put the negative sign in front. So minus 12 I2. That 12 ohm resistor purely lies in the loop 2. It is not lying between any other loops. So minus 12 I2. Okay. Next, we are writing minus 4 into I2 minus I3 and minus 4 into I2 minus I1. How it comes means, look at the other 2 resistors. So minus 4, this one, minus 4, it lies between loop 1 and, look at this, minus 4. It lies between loop 1 and loop 2. So we are writing the equation as minus 12 I2, that purely lies in the loop 2 equation, and minus 4 that lies between I1 minus I2, that is loop 2 and loop 1, right? So next resistor is minus 4. It is lying between loop 2 and loop 3. So we are writing that as minus 4 into I2 minus I3. So we will be getting equation like this. So after simplifying the equation, we will get the equation as 4 I1 minus 20 I2 plus 4 I3 is equal to 0. That is our second loop equation. So for the third loop, look at the third loop. Here we will be having two resistor and a voltage source, right? So the first resistor is 7. So as I said before, it is mentioned as minus 7. Minus 7, it lies between loop 1 and 3, no? So we'll be writing this resistor value as minus 7 into I3 minus I1. Why we are writing I3 minus I1? Since we are finding the loop equation for third. So third loop equation we are writing. So in order to find the third loop equation, we are writing the current as I3 minus I1. Okay. The next value is minus 4. Minus 4, it lies between second loop and third loop. So it will be like minus 4 into I3 minus I2. Okay. And plus, minus 600. Why we are writing here the voltage source as minus 600 is, in mesh analysis, by writing the voltage equation, the sign which comes to the second terminal, that is the second terminal sign, we need to put the second terminal sign as the voltage source sign. Okay, so here the second terminal sign is minus, so we are writing the equation as minus 600. Okay, like this we are writing. So after simplifying the loop 3 equation, we will be getting like 7I1 plus 4I2 minus 11I3 is equal to 600. So we got 3 loop equations, right? So from the 3 loop equations, we can able to find the matrix representation of 1, 2 and 3. So for matrix representation, we all know that the matrix form, that the constant terms will be denoted like the first column representing the I1, that is current, loop 1 currents, second column representing the loop 2 currents, and the third column representing the loop 3 currents. So let us see, look at the equation. So I1, the constant value in the I1 is 11. So we are writing the 11 as 11 here. That is first column 11. So in the second equation, what is the I1 value? 4. So we are writing the 4 as second one. Okay. So in the third loop equation, what is the I1 value? 7. So we are writing the constant value 7 here. So the first column representing the current in the loop 1, and the second column representing the current in the loop 2, third column representing the current in the loop 3. Okay, so after representing all the currents, we'll be representing the matrix equations like I1 into I1, I2, I3. The right hand side is the voltage source value which we got in the loops. So in the first loop, we'll be having the voltage source as 480 volt. So we are writing the 480 here. So second loop, we don't have any voltage source here. So we are simply putting 0 here. Okay. In the third loop, look at this. In the third loop, we are having 600 has voltage source. So we are writing that value here. Okay. So the left hand side includes the current flowing through the 3 loops, L1, loop 1, loop 2 and loop 3. Right. The right hand side indicates the voltage source in the 3 loops. Okay. The first loop voltage source is 480. Second loop voltage source is 0. We don't have any voltage source in the second loop. So third loop voltage source is 600. So thus we are forming the matrix representation. After forming the matrix representation, we need to write the matrix in the according to the Cramer's rule. So by Cramer's rule, we need to find the del value for the matrix form. Okay, so del value, in order to find the del value, we need to write the constant values in determinant. Okay, like this. So we need to write this constant values in determinants, and we have to find determinant for this constant value. Like 11 into minus 20 into minus 11 is 220 minus 16, that is, here they are cross multiplying this value and this value. So minus 20 into minus 11 is 220 minus 4 into 4 16, this one. Okay, so according to the formula, 11 into this section minus this value into minus this value into cos multiplying these two values. Okay, I hope you all studied in this matrix values in max itself. So the del value is 12 ohm. We got the del value as 12 ohm, right? Okay. In order to find the del I2, why we are finding the del I2 value? They are asking for the current in the 12 ohm resistor. Where is the 12 ohm is located? It is located in the loop 2. Okay, so we need to find the current value in the loop 2. We no need to find loop 1 and loop 3 currents. Okay, so they are simply asking the current flowing through the 12 ohm resistor. So directly we can find the I2 value. So we already find the del value. In order to find del I2, we need to replace that second column into that voltage source. Okay, so first column remains the same. Second column, that is I2 column, we need to replace that as a voltage one. So for voltage we wrote that 480 600, no, so that has to be replaced here. So after replacing, the matrix forms will be like this, and by simplifying this del I2 value, we will be getting like 8640. Okay, this is the del I2 value. So in order to find the I2, the formula for I2 is del I2 divided by del. Okay, so we already find that del I2 is minus 8640 and the del value is 864. By crossing the value, we can get I2 is equal to minus 10 amps. That is, the current flowing through the 12 ohm resistor is minus 10 amps. The minus sign indicates that the current is reversed. Okay, so this is all about mesh analysis. It's an important university question. In the first unit we'll be having this question, this kind of question for sure. So mesh analysis is important. So the next topic is mesh analysis by inspection method. So in order to find the mesh analysis in inspection method, the method varies for inspection thing. Let us see an example in this. They are asking for the current through the 8 ohm resistors as shown in the figure. So they have given the circuit like this, and they are asking the current flowing through the 8 ohm resistor, that is here. Okay, so the first step is, by mesh inspection method, we need to write the matrix equation. Here we no need to find the loop equation for all the loops. You know, for the mesh analysis method, in the mesh analysis method, we used to find the loop equations, right? For all the loops, we need to find the loop equation, and from the loop equation, we are going to get the matrix representation. But here in mesh analysis inspection method, we can able to directly find the matrix representation. For example, look at this circuit. Here we'll be having two loops, right? So by mesh inspection method, we can able to write the matrix representation directly. How can we write the matrix representation? So look at the loop 1. So in loop 1, we can able to see there are 4 resistors and 2 voltage sources are connected, right? What are those 4 resistors? 10 ohm, 5 ohm, 8 ohm and 5 ohm, right? So the 2 voltage sources are 15 volt and here 15 volt. So we can write this values in terms of matrix representation is, so there we write the resistor value as minus, no, here we no need to write the resistor value as in terms of minus. We just simply add the resistors which are lying in the loop 1. Okay, so look at this matrix representation. As we all know this, for a 2 cross 2 matrix, I11, I12, I21, I22 is the matrix representation form. So I11 is the pure loop 1, right? So I12 is, it lies between loop 1 and 2. I21 represents 2 and 1, loop 2 and loop 1. Okay, I22 is a pure second loop. Okay, so for pure loop 1, What are the resistors lying there? 5 ohm, 8 ohm, again 5 ohm, 10 ohm, right? So we are writing that resistors value and we are summing those resistors. Okay, for I2 we are writing that as minus 8. Why we are writing that as minus 8 means it is lying between both the loops I1 and I2, no? So for that we need to write as minus 8. And for I21 is minus 8. That also remains the same, no? So 1, 2 and 2, 1 both are same. So only 8 ohm resistors are there, that is denoted as a minus 8. Okay, so for pure loop 2 we are writing the resistors as 10 ohm plus 10 ohm again plus 8 ohm. So thus we are framing the matrix in terms of mesh inspection method. And since we are having only two loops, I1 and I2 is represented, and as we know that right hand side denotes the voltage source which lies between the loops. Okay, so first loop has 15 volt minus 15 volt. Why we are writing the 15 volt minus 15 volt is, look at this loop. So as I told earlier, we need to see the second terminal sign of the second terminal, voltage terminal. So what is the second terminal sign here? Plus sign. So plus 15. Here the second terminal sign is minus 15, right? Minus. So we are writing that as plus 15 minus 15. That is going to be our first loop voltage source. Okay. The next loop voltage source is plus 15 and plus 25. Okay, here look at this. Here the second terminal sign is plus. So we are writing that as plus 15. And here the second terminal sign is plus. So we are writing that as plus 25. So what happens? Plus 15 plus 25 is 40. Okay. So by simplifying this matrix representation, we can get the equations matrix like this, 0, 40. So by Cramer's rule, we need to find del for this matrix. The del value is 720. Okay. Next we need to find del I1. Why we are finding del I1? Since they are asking the current through the 8 ohm resistor. So 8 ohm resistor lies between I1 and I2, both the loops, no? So we need to find both the currents, which means the currents flowing through the loop 1 as well as the current flowing through the loop 2. Okay, so we already find del and we need to find del I1. So for del I1 we have to replace the voltage source in column 1. Okay, I1 column. So after replacing, we'll be getting the del I1 value as 320, and we know that I1 is equal to del I1 divided by del. So the value which we found for del I1 is 320 and the del value is 720. So we are getting 0.44 amps as our I1 current, and we need to find del I2. For finding the del I2, we need to replace the determinant value, that is second column, as voltage source value. We'll be getting del I2 as 1120. Okay, so for I2, del I2 divided by del, which is nothing but 1120 divided by 720. So we'll be getting current in the loop 2 is 1.55 amps. Okay, since they are asking for the 8 ohm resistant current, and the 8 ohm lies between both the loops, we need to minus the current value I2 minus I1. So 1.55 minus 0.44, we will be getting I is equal to 1.11 amps. Okay, so finally we got the current through the 8 ohm resistor. This is how we need to find mesh analysis using inspection method. So if they are asking the circuit in the mesh analysis, means we need to find the loop equation for the corresponding loops. If they are asking the mesh analysis in terms of inspection method, means we no need to find the loop equation, we can just go for the matrix representation directly. Okay.